discussed about carbonyl group when oxygen takes 2 electrons from double bond. Yeah? So in any case, if you have something, for example X, and if you have double bond with Z, for example, so these two groups. In this case, you have to be really carbonated. We interested in carbon. Okay, looks like X. If these two electrons, if Z has more electronegativity, than X. So 2 electrons transfer here to this Z atom, and you get next resonance structure, which looks like this. Here you have minus charge, here you have plus charge, like in ketones. Now look, C, CH3, CH3, C, double bond, O. So, you can write another version, CH3, CH3, C, O, here oxygen has minus charge and carbon has plus charge. So this is example of ketone. Next semester I discuss about enolate anions and not right now, but yeah, no. I discuss not about this section. Main structure of aldehydes and ketones, the most aldehydes and ketones have this structure. Then this one. But you have some cases where this form is favorable, then this resonance structure.
You will teach us next semester?
Yes.
Lecture, yes, but in class I don't know.
Well,
Lecture, I study on the lecture, but in class I don't know. It depends on my timetable.
all 8 semesters we have chemistry? All 8 semesters we have chemistry?
No, you have, I don't know what about, after organic chemistry you start analytical chemistry, and then you study physicolegal chemistry.
No, it's biochemistry.
Biochemistry and physicolegal chemistry too.
Have to.
But in analytical chemistry it will be Mr. Akaki, in physicolegal chemistry will be Mr. Gil. I give information only in organic chemistry. I can explain organic chemistry, general chemistry, and inorganic chemistry, but right now with pharmacy groups, I give you only organic chemistry course only. Now look, so this is one option. What about second option? When your pi electrons travel among all cycle, like in benzene ring, these 2 electrons move from second carbon from 1 to second to third and so on. So that's why in case of benzene ring, you can draw 2 resonance structures. So look, if these 2 electrons move here, these 2 electrons move here, and these 2 electrons move here. Finally, you get second resonance structure, which looks like this, and because of here you have 2 head error. It means that you have 2 resonance structures. And really, benzene ring is a mixture of these 2 structures. That's why for benzene ring you can write like this, its structure, cycle. So what means cycle? Cycle means that 6p electrons overlap each other. And of course you can here discuss about conjunction. Yeah? This is conjugation system. Cyclic, but conjugation system, because you have double, single bond. So that's why in case of if you have open chain molecule and you have two double bonds, here you have 4 electrons which overlap each other. like in 1,3-butadiene or 1,3-pentadiene. But in this case, because of you have 6 carbon atoms, all of them are in sp2 hybrid state, so all of them have 6p normal atomic orbitals, so 6 atomic orbitals all of each other, and you get pi system, not separately double single bonds, but pi system. And because of in benzene ring you have pi system, that's the reason why the additional reactions with benzene ring goes more difficultly than substitution reactions. Substitution reaction is a more common reaction for benzene ring than addition reaction. But stop on this point because in this case you have in this paper all these reactions. So about this I discussed when I explained types of reactions. So what means addition, what means substitution. In any case, you have to know this from school course. But you don't know. You don't know. It's very good. Now, third version is when source of electron pairs or pi bond next to positive charge. Now, if you have this version, and here you have positive charge. So, these two electrons, pi bond electrons, are source of this double bond, of electron pairs. So they can move to this carbon atom, and in this case, you can draw another resonance structure, and here your positive charge goes. Or another version, if this goes here, so you get this one. So this is version where you have pi bond next to carbon which has positive charge.
Okay.
Or something which has positive charge.
Any exam you will bring which one is correct for?
I don't know.
No, because you don't understand how it has that.
Stop ask this type question because I don't know. So your aim, understand the reason. If you have here questions, please ask me. You understand this or not?
Yes.
Guys?
Yes, it's easy.
Yes, it's easy, I think. Then here you have a fourth version where you have atom in the structure which has lone pair. If you have lone pair next to positive charge, once again lone pair is the source of this electron pair. For example, if you have this structure, look, here you have oxygen which has lone pair, and here you have positive charge. In any case, for movement of these two electrons, you need source. In this case, this is your source. If these two electrons move here, so what you get? Which structure? You get another structure like this. Look, here you have oxygen in the middle because of these two electrons. Here, so you have double here, and here you have plus. Why? Because Oxygen gives 2 electrons. So in this case, oxygen has plus mesomeric effect here, because this one is donating this electron pairs, and this carbon has minus inductive effect. Why? Because of he takes these 2 electrons. So in this case, you can draw this structure. In another version, if these 2 electrons move to this oxygen, so you get this. So finally, you have mixture of several resonance structures. And remember, please, if you can draw several resonance structures, molecule for which you can draw more resonance structures, this molecule is more stable. Less resonance structures means that this molecule is less stable. More resonance structures means that you have more stable molecule. So why? Because of you have distribution of electron density among whole molecule. And fifth one. Now let's discuss about this.
What is
Once again, here, really, you have what? You have a lone pair or a negative next to a pi bond. It's really the same. Somebody speaks in Russia? Yeah?
I said that is true.
You know Russia?
No, somewhat.
Нет.
Somewhat? Somewhat. It's very difficult.
It's easy. It is more than Georgian language. Georgian is difficult for us.
Georgia, grammar of Georgia is very difficult.
It's not about the grammar.
No,
it's
the
about
word,
pronunciation.
The word
Pronunciation of course.
Yes.
But Russian
You
is
have
easy for us.
We have also J, K,
K, Ha, Jim, Ha, Dal.
But for Georgians, something is from here, from the voice.
Yes,
What comes from
stomach.
Yes, yes. I agree with you.
Yes.
For us, it's very easy language, but in any case, Georgian is the oldest language. So, in world, only 14 languages have their letters. Only 14, and one from them is Georgian. Yeah. Now let's discuss about this. But Russia is very difficult too. But not for me. Georgia, Russia.
I think all of Georgian people think
Horrible.
they know
Yes, because,
Russian.
yes, because of we were in USSR.
Soviet.
Okay.
So till 109-21. We lost your independent as a country, and we were in USSR as some part of USSR.
Which one is better, now or before?
I think
You know, I lived in USSR and in Georgia Republic now. Of course, freedom is better than being in some country. You are free now.
Yes.
In any case, yes.
But now Georgian is like not weak. Weak,
Not
not
strong.
strong.
Yes.
Not strong.
No, because
No.
you know anyone, if Russia wants something, they
Georgia-
can't take it.
Georgia-
America, they want something, they can't take it.
Georgian always fighting with animals. Always, because it's a very beautiful country, and we have
No, you know, there's a...
we have the
Community.
position like we're on the cross of west and east, and always countries from west and from east always fighting with each other.
Yes,
with their object.
that's why.
But
But
in
now,
any
like
case,
Russia, no one can speak with them.
you know, you see, now when we discuss about our country, so in any case, freedom is better. In any
Yes,
case.
sure, because
For you, of course,
our
because
country
of in
also
this
it
case.
was not freedom. We don't have freedom before. Now we came. It's you know when the
So you are from
They
Iraq.
give freedom, we get.
You are all of you.
But now
all
we get horrible.
of you from Iraq.
Yes.
Yeah.
Yes.
But now,
Yes, I know
now
that.
Iraq is-
everyone said before.
You was
because-
fighting with Iran and.
Yes, with
Kuwait.
Iran, with Kuwait, with
Tough
one
guy.
time with Jordan,
Tough
one
people,
time
they are
with
tough people.
America, and with Turkey.
Yes, it's
Israel,
very,
with Israel.
it's not doesn't easy for small countries with little territory.
No, because of we have
Uh,
petrol, they won't take petrol,
Yes,
so we have to fight.
Yes, of course.
It's like
Like
this.
now, what's happened for Ukraine? When Russia says something, it's enough,
You
it's
saw,
done.
it's now today's situation is what? So So they want to return USSR
Yes, like
situation.
If they take,
Yeah.
I think,
So they want to reduce this USSR.
if they take
That's
Ukraine, I think
why
they
they
take
fight
Georgia.
with Ukraine. They fight with us. We have we lost our territories. So it's Ossetia, it's Abkhazia. It's,
Oh, Abkhazia.
it was our
2008.
territory.
2008.
So yes, and like independent country, they are not independent.
yeah, it's like now Turkish also they want to take this part.
Yes.
Rather they took
Really, I which how many territories? So if you start from 18th century, we lost 2/3 part of our territory. 2/3.
It's too much.
Yes.
Yes, but
1/3
we
in
saw-
Turkey.
we
1/3 of
saw
our
some-
territories is in Turkey.
yes,
In Russia, if you know Sochi, it's our
yes, this
territory.
mountain,
Sochi, its name of this town goes from the tree name. It's Sochi, like Christmas tree.
Mm.
Sochi. It's another kind of. So it goes
Mountain.
from Georgian name.
Okay.
From Georgian name.
we like something from Georgia, and they like them history, not like another country. They don't care for the history. You know that? Like they have some traditional for Georgian people. They like the country, and they don't want anyone to come to play anything with this country. And they like all the traditional and all things, not like another country. Always they searching for.
Suppose some people
And
like
for change.
America, suppose some
Change.
people like Russia, but Georgian people they like themselves.
So you know it's a very famous phrase of one leader of USSR. Georgia is a better country without people. Without people. So they need our territory. That's all. It's our problem. They need territory. Russia needs territory, our territory. Because of we are on the cross of West and East. That's why. And all countries, that's why I'm fighting.
You have Russia and we have many
fighting
enemies.
with-
You have
Yeah.
just Russia, we have many.
Yes. But I like Russian. You know, not all Russian people think like Putin or other.
Yes.
So some
Russian
of them.
people, they are different 100% from
Really,
the government
Russia.
and from
Russia is a
People.
multi-country which contains a lot of small countries right now, at this moment too. At this moment too. And Alaska was Russian territory too. Yes.
Oh, but no Russian fire.
Now look, let's continue.
Okay, now continue. We make
Now
sense.
look, if you have this molecule, okay, once again, if you have this molecule, in here if you have minus charge. So this is a version where your pi system is donating this electron pair, and this group donates electron pair. So do you see difference between them? In this case, when pi bond next to positive atom which has positive charge. In this case, this pi system is source of electron pair. So in this case, this group has minus mesomeric effect, and pi bond this has plus mesomeric effect. Why? Because of two electrons move in this direction. Now look in this case. What you have here? Here you have with the pi bond next to minus charge 8. So in this case you have another direction. So these two electrons move here, and here this pi bond gets these two electrons. That's why this one has minus mesomeric. Oh, sorry, plus. Just a moment, I
Yes, plus.
I will something. Just a moment. This is here. Yes, plus, and here you have minus mesomeric effect. So in this case, double bond is get these two electrons. In this case, this one gives two electrons. In this case, pi bond is acceptor. In this case, pi bond is donating group, donor of electron pairs. In this case, this one is acceptor. But in any case, you can draw for this one another version of resonance structure where your double bond moves here. Yeah? So here you have double bond, here you have minus.
So to be okay? If you will draw like this?
Like this. So you have two structures. This is one version of distribution of these electrons. Now here you have about OH groups. I show you this version and I will not discuss about this. Yeah, when you have benzene ring and OH in the benzene ring. Now next one here, when you have something atom which has a lone pair and which is next to pi bond. So in this case, once again, your pi bond acts as acceptor of electron pair. Well, so arrow shows you from which part your two electrons move to which end. Arrows shows end of the arrow always is source of these electrons, and its head always is a place where these two electrons go. Now, if you have here, you have O with double bond, and here you have something. For example, second O, or something, or nitrogen. It doesn't matter which one you have here. Now, here you have lone pair and source of this double bond. Acceptor of these electron pairs. So if these two electrons move here, so you have to break this bond, and finally you get this version. Good.
Double bond here.
Single bond.
Yes, double.
Oh, and this oxygen gets minus charge, and this oxygen plus charge. Here you have double bond. You got it?
Yes, we understood. Now every electron, we playing with electron.
Yes, yes. So
Your
always
body
look
was
where
just
your
fixed.
arrow goes, from which place it starts and where it goes.
Yes,
So
we got
this
electron
fourth
and
arrow always shows you way of two electrons. And once again, mesomeric effect of transfer of two electrons. Transfer of two electrons. So
why you put one?
No, this by mistake.
And here.
No, this one, it's by mistake, this one,
This one.
for carbon, because...
The last line of
The last
this.
line.
Yes.
yeah. You understand?
Yeah.
So what is the next? Now tell me please, which one has plus mesomeric effect and which one minus mesomeric?
Yes, this one, oh.
Plus mesomeric. What means plus mesomeric? Which
Which gives
Which
this
donates.
one.
Oh, this one.
So
This
this
one,
oxygen has plus mesomeric effect, and
This
this
one.
oxygen has minus
This
mesomeric
one.
effect. Now, if you have this version,
This is two.
where I have to write.
Yes,
Yes,
it has to be plus.
Double bond.
Here,
For
double bond.
Oh,
yes,
this
plus.
one has
Plus.
plus mesomeric
Yeah,
Yes,
effect.
and this
Yeah,
minus.
double bond.
Yeah,
This
so
minus
this
and-
double bond moves here.
Yes.
Yeah? So finally, you get this structure. O minus.
Minus. Double bond.
Single bond.
Ah, no. all without minus, sorry, plus. And here you have double bond. And here you have plus, or minus. So you have,
And again we have double bond here, or not?
this double bond.
No, what about this?
This, so you can continue. You can continue. If these two electrons move here, these two electrons move here.
Okay.
So finally your double bond forms here, and here you have single bond. So you can change. That's why you can write several structures. This is an OA denial. I hope that you understand.
Yes.
Yeah? You understand? So, once again, for mesomeric effect or for resonance, you always need source of electron pairs and something which gets these two electrons, this electron pair. So, which one can be connect as source if you have pi bond, or if you have a lone pair, or if you have an ion minus charge. So in this case, you can discuss about mesomeric effect. Now look, if you have this version. In acetate anion, CH3C double bond, O minus, and this oxygen has 2 electrons. Here, for this anion, you can draw resonance structures too. Now look, if the 2 electrons move here, and these 2 electrons move here, so you get another structure. CH3, C, all here you have minus and double bond O. Yeah? So you can draw 2 structures. That's why for
This is to be.
Sorry, here. Yeah. So for this molecule, you can draw really resonance hybrid, which looks like this. O. And here you write in the middle minus. Why? Because of the 2 electrons travel from one carbon to another, from one carbon to another. So really, your electron density distributes among 3 atoms, 2 oxygen and 1 carbon atom. The same situation you have in nitric acid. For nitric acid, you can draw 2 resonance structures. Do you remember resonance from general chemistry? From general chemistry. You can draw nitric acid like this. Double bond with this nitrogen, double bond with this nitrogen. Do you remember these 2 structures? This is one version, and second version is this one. H-O, N-O, double bond O. So finally, really, the structure looks like this. Resonance means that you have a directly single bond, directly double bond. You have something in the middle, like in benzene ring. In benzene ring, bond angle, bond length, bond energy is in the middle between single and between double bonds. Why? Because of here you have once again resonance structures, 2 structures. You can draw 2 structures, and really you have some hybrid of these 2 structures. So that's so wonderful.
Please, we are so tired.
Okay, so once again, 2 words. How this inductive effect or resonance effect act on the molecule. So they change their strengths, they change their basic character or acidic character. Then they change equilibrium of the reaction, they change reaction rate, and so on and so on. So these effects are very important for us, for organic organisms. Now, one example. I show only one example. Only one example. Only one example. How this effect works. Of course, you don't need this reaction, of course. I only show their action. Now look, if you have benzene ring, after chlorination of benzene ring, you get monosubstituted product. So plus Cl2, here you get molecule, this one, chlorobenzene.
Yes.
So this is substitution reaction. Instead H atom, here you get chlorine substitutes one H atom, which has
So what
each
is-
carbon.
What is that?
And plus HCl.
Yes.
But if you carry out chlorination of phenol, where you have OH
Oh,
group.
yes, we know.
Now, if you take phenol, where you have OH group, by action of this OH group, you have more electron density in ortho and para positions. Here, here, and here. Because of OH group's plus mesomeric effect. And finally, after chlorination, you get product where you have 3 chlorine atoms. Here, here, and here.
And three.
Yes, and plus 3 HCl. As you see, here you get 3 substituted products. Here you get monosubstituted product. So I can vary the product of my compound if I substitute correct groups. In which position I can direct my chemical reaction. In which position I need some group. In which position. By this substituent and by mesomeric and inductive effect, I can change my reaction product structure. So this is example. You don't need this reaction. I show you only